Let's continue by creating a profile plot from actual data that we're looking at here. We're looking at this SST in the Mediterranean region. We've learned how to create a empty geometry container. We give it a name. We select it and use one of the geometry drawing tools to add geometry to it. In this case, I'll just do a simple profile line. Immediately leave the drawing tool, and then I can select from the analysis menu the profile plot item. Now this brings up this user interface, which has no profile plot in it. Your window may be smaller and hiding some of this user interface, so stretch it out to a size where you can see everything that you might want to control in making your profile plot. Two things have to happen for data to appear here. One is you have to have selected one of the bands that you want to run the profile, and the other is to select the geometry. Now in this case, it probably just found the one geometry that we just drawn, and so it drew the plot line. But this is sort of the default appearance of the plot, and we have all of this user interface to control what this plot is going to look like. One thing to notice is if I use the selection tool up here and pick one of these handles at the end of my profile line and start moving it, the profile plot changes. So this plot is sort of dynamically responding to the geometry that I'm reshaping in the data window, which can be a useful feature. But let's go over the user interface elements of the appearance of this plot. And first of all, what I'm going to control is the scaling of these axes. We've got a little range of data and a big range of axis values because that's been controlled automatically, as is the default. So I'm going to uncheck auto min-max the y-axis, and I'm going to kind of eyeball it and say, well, a value of 25.0 might be a good minimum. I'll tab to the maximum value and maybe just set it at around 32.0. Okay, and so now that's shifted the data within that range. For the x-axis, you'll notice that, well, it starts at the 0th pixel along the path and counts out to the last pixel of the path. It seems to have found that I drew a line of about 565 pixels long. If you want, you can modify that. You could either truncate some of the data by making that shorter. Let's make it very short, but you're losing data there. Okay. If I went back to, say, there and had a little bit of a region, I could actually pad the start of the file by putting simply a negative value for the axis there. But you're going to have to sort of play to make things look symmetrical, and you'll spend hours making it aesthetically pleasing, but the data is what's important. Okay, so anyhow, you can control the min-max of each of those axes to position the data. Now you'll notice that the line is drawn heavy here, and there's this sort of blurry range of values around the plot. That's actually giving you a standard deviation around the data points, and that's controlled by this box size. So this is a sliding box over the data, and then taking a standard deviation from that to give you some view of the variance around the data. This has to be an odd number so that it's a square box with a center of pixels to choose from. If I run that up just arbitrarily to 7 and tab out, I get this broad standard deviation portrayal here. you'll notice it kind of smoothed the data as well. If I bring this down to 1, I'm getting actually just the raw data. Okay. Now this checkbox here for compute in between points, that's just going to give you your 2 endpoints, but you might want to utilize that if you were using a polyline instead of a line. And so if the joints along the polyline were the important data, you could remove the computed data in between that it's found along the way. Now, going to the top here, you've got sort of a refresh icon here, but more importantly is this switch to table view, which gives you a actual sort of spreadsheety table full of data, and you've got each pixel X and Y and each latitude and longitude and the SST that it's finding there. Because it's interpolating along the line, I would strongly suspect why it's labeling this the SST mean, so that's why we saw when we go in this corner back to the plot view and raise this box value, let's just make it really large, something like 15. You see that the line along the data is heavily smoothed here, and so the data that you're seeing here is not as many points, and I believe that's true, but anyhow you're seeing a sigma and a mean value portrayed in this tabular view. Let's run this back down to 1, and let me just double check something. No, it's not changing the number of rows. It's simply computing that sigma for the box size that you give. Okay. So with the table view selected, you can use your computer operating system's select all command, which might be Command A or Control A on a PC, and then the copy paste. If I Control C or Command C, I've copied that into the paste buffer. I can paste that data now into a spreadsheet program of my choice and do whatever analysis I might want outside of CDAS with that data. So you do have access to the data, but it's not through some direct export operation. You simply copy and paste it from this table view. Okay. Down here at the bottom are a few more tools. This first one would reset the axes range to zoom in on all the data. So, that just clicks it back to look at all the data. But I can sort of use these values that I've chosen here and get back to the plot that I was looking at before. This next one, the typical page and pencil, is for editing the plot. So this lets us look at the chart properties in 3 groups. One is the title, which allows me to change the text of the title of the plot. So maybe I just call this SST profile in Adriatic Sea, just to illustrate. And choose my fonts and my colors, and then I can choose the label for each of the axes here in this next plot group of the chart properties. So the domain axis is along the x-axis there. So if I were to change that from path in pixels to something, it will be reflected. These changes won't take effect until we say OK here. We can turn on and off tick marks and tick labels and so on. We can do the same for the y-axis. Let's just, for fun, put a capital SST in there. We can control a little bit about the appearance here, and whether this background is gray or not. You know, there are various, you can color this up and customize it to your heart's content. This other category is looks like you know, whether you're doing any alias, which I would leave checked. These are just other features for the appearance of the plot. So when I click OK, the title changes, the y-axis label changes. This next tool down here, however, is the one that allows me to export this as an actual image file. So I will just call this Adriatic underscore profile, and when I save that out, what I get is Adriatic underscore profile.png, so it's a graphic file. And you'll notice that the extent of this image mirrors the extent of the window that I created it in. And to illustrate that, I'm going to close that preview of that, and I'm going to go back to my plot making window and stretch this out. So this is you know, a feature or a limitation of CDAS, however you wish to view it. But whatever the plotting window here is showing is really reflected in what you end up saving out as the final image. If I can grab that and just drag it a little more, okay, and just to show you, if I were to you know, turn the standard deviation back on, turn these off, let's go from, what did we say, 25 to 32, and we can maybe go minus, what do we say, 15 there, and go to 550 here, something like that, okay. And then when we export this plot again to Adriatic profile 2, and save that, we get a similar plot, but notice that its aspect ratio now reflects what I was viewing in CDAS, and exported it in that state. Okay, so if that's sufficient for plot creation, you can create your plot within CDAS. If not, then I suggest you use the spreadsheet feature and select all that data, copy it, and then paste it into a program where you can do your own sort of analysis and plot making with it. Okay, and there is a print feature here if a printer's available to you. So that's sort of a quick overview of the profiling using a simple profile line in CDAS.